Case number 26. Here we are going to verify or check this identity. We have 1 plus sine theta all over 1 minus sine theta is equal to cosecant theta plus 1 over cosecant theta minus 1. We are going to manipulate a certain portion of our equation and see if that manipulated portion will be equal to the other side. Now, in the previous videos, we were able to manipulate the left-hand side, and we are trying to check whether its form, simplified form, or other form can be equal to the right-hand side. In this case, the left-hand side is actually simpler than the right-hand side because we have sine theta that can be found in both numerator and denominator of the rational expression on the left-hand side. In this case, and in other cases as well, we can choose to manipulate the right-hand side, because the cosecant theta that can be found on the rational expression on the right hand side for both numerator and denominator can be transformed into an equivalent expression including sine theta. So again, where it's a decision on what side you're going to manipulate. Actually, for some cases, you could even manipulate both sides. But again, in this time, we are just going to manipulate the right hand side and see if a certain form of that can be equal to the left-hand side. So let's start by looking at the term or the identity cosecant theta on the numerator and denominator of the right-hand side rational expression. Take note that cosecant theta can be expressed as a reciprocal of sine. So we could have here 1 minus sine theta. That's the equivalence of our cosecant theta plus the entire integer 1. This could also be true to our denominator, 1 over sine theta but minus 1 here. So we are done expressing cosecant theta in terms of sine theta. The next thing here is, how do we make this simpler? And of course, we have seen already the sine theta and a minus 1 and plus 1, which is actually important in our left-hand side. What we could do here is to just combine first the expressions on our numerator and denominator separately by, of course, looking for LCD. We know that 1 can be expressed as 1 over 1, or any integer can be expressed as a fraction of denominator 1. With this, we can see here that we could come up with an LCD on our numerator alone. Let's start with the numerator, sine theta and 1. The LCD for that is their product, sine theta. Okay, that's the LCD for the expressions that can be found in our numerator. And after that, we are going to combine them. So, by this, sine theta divided by sine theta is 1 times 1, 1 here. On the second, sine theta divided by 1 is sine theta times 1, you have here sine theta. If you are not convinced with this process or your answer, simply look at this. If we're going to isolate the first term of the numerator together with our denominator, this is the same thing with the first term. Okay, 1 over sine theta. If we're going to isolate the second term with our denominator, sine theta divided by sine theta, that's just equal to 1. So we are not changing the actual value, we're just changing the expression. But don't forget, there's one more. This is plus, so you had here plus. Let's duplicate the process in our denominator, and the LCD is still sine theta here as well. So the same process, sine theta divided by sine theta is 1 times 1, 1 here. Sine theta divided by 1 is sine theta times 1 sine theta here. Again, you may isolate the terms on our numerator and check whether it's just the same as your expression here. What we need to add here is just the subtraction. Now, before we proceed to the next step, we could actually see now a portion on this expression is similar to our left-hand side. We already have 1 plus sine theta here. We also have 1 minus sine theta here. The goal now is how to reach to that from here. Take note, we are dividing two rational expressions. By the way, you cannot cancel this because this is a binomial expression, okay? So what we could do here is the keep, change, flip method. Instead of dividing them, we're going to change the operation into multiplication. And the keep, change, flip method tells us this. Keep the entire numerator or your dividend, 1 plus sine theta all over sine theta. This is just your numerator or your dividend. Okay? You kept that. Instead of division, change the operation to multiplication. So keep, change, and you flip this, reciprocate. Okay? You flip or you solve or you give its reciprocal. 1 minus sine theta. Now, instead of division, we have here multiplication because we have kept, changed, and flipped our expression here. From this, we can see a portion of expression with sine theta and sine theta here as well. So by cancellation law for multiplication, this could be cancelled out. But don't cancel this as to that, okay? This is binomial expression divided by binomial expression. It cannot happen. Only for monomial terms such as this. Sine theta divided by sine theta, that's 1. So the final expression would be the terms that are left on our expression here. So we have 1 plus sine theta. Okay. Of course, this is over times 1 over, you'll have here 1 minus sine theta. Notice anything? Yes, this is the entire expression on the left-hand side of our original equation. And with this, we have verified that really the right-hand side can be expressed as the same as the expression on our left-hand side, and this is an identity. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.